Hi, good afternoon, everyone. Thank you for joining us today. We will be getting started in a few minutes. We're just going to give a few minutes to allow participants who are just logging on to the webinar session to have a chance to log in. I appreciate your patience and look forward to beginning shortly. Thank you. Once again, a very good afternoon to all of you. On behalf of Kripya Solutions, I extend a very warm welcome to all of you joining us for today's webinar, covering ERP, MES, and IoT solutions, creating a connected manufacturing ecosystem. My name is Sri Kumar, and I'll be your host for today's session. We are truly honored by your presence and appreciate you taking the time to be with us. We have an exciting session planned for you with some great insight from our expert speaker. Towards the end of the session, we'll have a Q&A, so feel free to drop your questions in the chat or QA box through the webinar's windows. Now, it gives me immense pleasure to introduce our speaker. Joining us today is Satyanarayana Chebulu. He's a seasoned leader with over 30 years of experience driving digital transformations in IT and manufacturing segments. He has successfully led and delivered projects for customers in the global smart manufacturing space across diverse sectors, including automotive, industrial manufacturing, and discrete production. With deep knowledge of IoT, MES, and intelligent automation, Satya brings a strategic perspective on how to build connected, data driven manufacturing ecosystems that scale. Without further delay, let's begin. Satya, over to you. Satya, if you're speaking, we are not able to hear. I'm not sure if you're on mute. Satya, just rechecking. The voice is not coming through.
Are you able to hear me now?
Yes, we are.
Yes.
Thank you.
All right. Good afternoon, everybody. I today will be talking about the data, the way it flows across the organization, and how it plays a role in making it smarter, better, and more efficient. So, just let's consider an enterprise that is manufacturing a particular product. Now, if you see the enterprise would have a product design department which would be taking insights from its marketing team and then defining what the product should be like. And they use various enterprise tools like CAD, CAM, CAE, and PLM, PDM to design their product. Now, once the design is done, it is given to manufacturing for production. Now, for manufacturing, you need suppliers, which means that the ERP systems like SAP, Oracle, and others would come into play in managing suppliers, in managing materials, procurement, finance, costing, and all those things. And once the manufacturing is done, it goes through the delivery team to deliver the product, where the logistics and CRM all comes in. And through the CRM, you get your feedback to into the enterprise as to how the product is performing in the market. And then based on the feedback from the market, you go about again making changes and release different models of the product into the market. Now, while doing all this, there is a production plant that manufactures the design that the engineers have come up with. There are managers, line managers who will monitor the production, and there are senior managers and executive leadership who will be looking at the performance of the product in the market and then taking strategic business directions. Now, in all this, you would have seen different enterprise functions like an ERP, a PLM, and a manufacturing execution system in the shop floor, which would be essentially giving you the uh, uh, 360 degree view of how the product is performing. Now, the production plant, as it manufactures, the executives want to see how the plant is performing, and then the directions from the executives flow down to the production plant to meet a specific business demand. Now, given this, let us look at what are the various products in play. We PLM being product life cycle manufacturing, you have three major players there that are supporting the system. One is the ERP, like the SAPs, Oracles, and others, which would be doing the enterprise functions like finance, HR, costing, logistics, CRM, and all those functions. Then from there, if your engineering is dependent on the PLM or PDM product, which essentially is your CAD engineering, your manufacturing processes, and your computer aided engineering. This basically defines your product. And then you have a manufacturing segment where you have execution that is taking place, the controls that are there, and then the planning that is fed to the manufacturing execution systems called MES. There are various softwares for MES as well. Now let's look at how the data exchange happens. The PLM will release the master plan or the bill of materials to ERP. ERP will release the work order to the MES. MES will take that into production to create shift-wise plans, and then if there are issues in manufacturing, it will feed it back to the PLM, and as the product execution system completes the execution, it feeds back the data of how many parts it has produced back into ERP. ERP will then do the costing and then release it to the market for shipping. Now, with this kind of a data exchange that is happening, if you go to the next slide, if you see that the data of various functions within the organization that are all driving towards the product being successful in the market or meeting the design aspects of the product, there is several data elements that flow across these systems. Now, from PLM to MES, you will find the PLM supplies detailed product data, CAD models, bill of materials, EBOMs, MBOMs, and work instructions to MES. MES in real time will take the production data and then feedback to the PLM as to what are the challenges it is facing. Should it go back to the CAD and modify the engineering design of the product to ease manufacturing? Similarly, the MES to ERP will give the production status as to how many parts have been produced and what are the labor utilization, material consumption, because so that the ERP can in return place the orders for the future orders for materials for the future production. Now, ERP on its side will take all the data that it has got from the PLM and create production schedules, material requirements, and work orders for MES to execute. And the PLM to ERP would be basically the data that the PLM would share, including design changes, version controls, etc., with the ERP. And the ERP will communicate with the production planning and scheduling information to PLM to align manufacturing with design specifications. Now, if you see, all this while we have been talking about various enterprise engineering and MES systems, where is IoT in all this? So IoT is where the data gets generated or through the sensors. I'll just give you a layout or the architecture of how the IoT plays a key role in the production process of any product. Now, there are various sensors across the manufacturing segments. either and actuators and smart devices that are there in the shop floor, whether it is the CNC machines or the sensors, vibration sensors, temperature sensors, pressure die casting PLCs. There are a lot of PLCs that are there in the shop floor, which are constantly generating data. Now this data is picked up and through the gateway is sent to the edge server, and from the edge server it can be taken to the cloud where the streaming data can be to the streaming data processor, and the sensor data can be pushed to the data lake for further processing, to put it in the warehouse and run your analytics. Or the same sensor data can be sent to the control applications which can analyze the data. Let us say if a particular temperature is getting higher in a furnace or in a heat treatment plant, it can go back, send the data back to the cloud through to the edge server to alert the operator or the alert the actuator to reduce the temperature. So this is how the data is generated, and as the data is generated, there are web applications and mobile applications which consume this data, and if there is any additional business logic that is to be brought in, that logic can be applied on this data and again given back to the control system to make necessary changes on the actuators and the smart devices. Now, if you see, there is significant amount of data that is being generated across during the in the organization. The benefit of harnessing this data to meet your key performance indicators is to run it with analytics and data models where the leadership can take informed decisions or data driven decisions. Like I said, the executives at the top have separate key performance indicators, while the line managers and the operators have a separate set of KPIs. So the information can be constantly reported back to the to various levels in the organization to fine tune the production process or the engineering design or the MES systems. Just to draw an analogy, it's an organization or an enterprise is almost like a human body, where the human body, collects data through the five different sensors, which is the vision, audio, taste, touch, and what is the fifth one? So through the five senses, as the body collects data and passes the information to the brain, which is the CPU, which then processes the data, you can be like your the blood that flows through the vein. The key thing to remember in all this is having data alone is not enough at a repository. It has to be made available to the right device at the right time so that the actions can be taken uh, appropriately. Just as your senses convey that if something is hot when you touch it, you would immediately take your hand away. Exactly the same way, when the data communicates critical information about a product performance or a plant performance or a line performance, the line managers of the respective functions, I would say people, have to take necessary actions to ensure the situation is addressed and the data that is coming from the sensors is processed for the organization to function efficiently. Moving on, now now we have got all the data, we have got all the sensors in place, we know the process. Now the world has moved away from physically trying and testing it, and if it doesn't work, change the design a little. From there we have gone towards what we call digital twins. There are three types of twins. One is a product twin where the engineering design can actually be visualized and played with, and we see how it is going to perform, how is it going to fail, what stresses it faces. Through the engineering design, you have a product twin created, which is a virtual digital representation of the actual product that is going to go out into the market. Now from there you have a process twin which basically does the entire simulation of the process that is used to manufacture the product. Now, in this process, what happens is when you take the entire plant, simulate it on the process train, you can actually see where the constraints are, how the material is flowing, how the machine is operating, how the conveyor speed can be altered, or the process times can be altered to make sure that your production throughput is met, or your different models that you want to manufacture in that line can be optimized to meet your production goals. Now, the MES, which is the real system that is actually measuring all this, is the real production from where the data is coming back to us. Now, with this data, you can also go back and see how the product is performing. Once the product is released to market, you have your feedback systems through which you can collect information how the product is performing. Let's say you take an example of a car that is delivered. There are onboard OBDs, onboard diagnostic tools, that are there today to pick up every possible snag that the car can develop and report it back, along with the circumstances in which the snag was developed, and hence take it back to the product twin to see if any fine tuning is required, or is it a user error, or is it a situational error that caused this. Like this, these twins help to foresee the possible challenges well before the first brick is laid or the first part is manufactured. So the process twins actually harness all this data that's coming from multiple sources into the twins. And the process twins are more applicable in a process industry like a aluminum or a steel manufacturing company, while discrete manufacturing companies would use product twin to design, and then the process twin to simulate the entire manufacturing process, and the performance twin to take the feedback and constantly improve the product. You can see that in the today's world, as you see more and more mobile phones being coming out of the market with different models of iPhone v6, v5, v10, v16, v17. Each of them is an improvement based on the performance twin giving feedback to the product twin, and then of course the process twin lays it out in the production process. Now that we have the sensors giving data, we have enterprise applications generating data, and then the process twins, the digital twins simulating all this. Where do we go from here? What are the benefits of doing all this? Once you connect all these dots, what it will do for the organization is it will improve its quality and traceability of the product, gets a complete view of the manufacturing process and identifies potential issues, and reduce rework and improve overall quality. Then you'll also see there's an improved resource utilization. Now, we talked about process twin. In the process twin, you can actually see where the bottlenecks are, remove the bottlenecks so that the entire line is balanced. It can also integrate with your supply chain to tell you which part has to be at what station at what time, so that you can place your order given that you know at what lead time it is required to get the part into the shop floor for assembly. So it will improve your resource utilization. You can focus more on getting just in time availability of resources, and then waste is removed, and hence your efficiency of the organization goes up. And one additional benefit of all this is improved data visibility. Now again, we're back to the data, which is the blood that's flowing through the organization, which is the new currency. So everybody wants to look at data near real time. And with these IoT devices and enterprise applications connected to MES and other systems, you have near real time information of your shop floor, where you can take informed decisions and identify where possible challenges are. Let's say if one particular supplier is delayed in particular production of their part that is needed and is critical to my production plan. Once I know that, the leadership and the managers online can look at alternate sources as one option, or rejig their production plan to ensure that the manufacturing process is smoothly continuing. So there is data driven decisions that will help leaders to make sure their organization is one, resilient, is able to adapt to changes or situations, and then can be run efficiently despite the variances from the market. Now, there are different tools in the market which will help you visualize this. One is from Siemens, where I took this image, where they have a MindSphere product which basically connects all your IoT devices, and Technomatics is their tool where their entire plant can be simulated for visual commissioning, optimize your control strategies. You can generate your market driven data decisions, data market data driven decision. Based on that, you can streamline your production, detect any process interdependencies, reduce rework, reduce footprint, reduce capital expense. If there is wastage, you can always remove that, or you are buying too much of one particular material which is not needed, you can reduce that. You can optimize your throughput time and increase flexibility to adapt to changes. Similarly, there's another product from Autodesk called FlexSim, which can actually simulate the entire shop floor and give you, once you feed the necessary information at all the workstations for an assembly line, you can see the line output, the way it would behave given the constraints you have placed on that particular assembly line. And once this is done, you can actually tally it to plan versus actual when the actual production plant is performing. And if there is a gap between the plan versus actual, if a production plan is given to a particular plant and they find that their throughput time is different, then we can go back into this and fine tune as to why, and then make changes and then optimize our so Flexim offers that. Now, what are the layers of data exchange that happens when we are talking about an IoT based or a connected enterprise? The automation is where the virtual PLCs and HMI simulation comes in. Component and periphery, you have IO simulation. Component physics, you have different simulations. Production machine, there are equipment level mechatronic simulation available. Robotic line, you have line or cell level simulation available. So from production line factory, you have plant simulation. So the data from these sources on the left, there is, it can be simulated on the simulators on the right to ensure that the the reality is in sync with what the virtual world is telling you. Moving on. Now, why do we do all this? We at the idea for us is to create a AI/ML solution which basically consumes all this data and gives you indications as to what are the possible optimizations you can do from supply chain, how you can after monitoring the production process, how you can modify the production process to ensure that it is leveled and streamlined and balanced. You can manage your inventory both inline and in store to ensure that your order levels are placed ahead of time to ensure just in time availability. You can track your assets the way they are moving in the shop floor. You can measure the energy that your plant is consuming and then find ways of optimizing it. Of course, quality being sacrosanct in all this, you can actually look at how the quality of the product is and then do course corrections if there is persistent repetitive problems that are happening at a particular station. One of the other most important things is safety, where historical data, once the is available, the AIML model can actually take all data elements, direct, extraneous and internal, to predict possible safety issues in the shop floor. And in addition to all this, this engine can help you predict your machine downtime based on its usage and historical data, and also alert you as to when you should undertake a preventive maintenance of specific machines that are critical in your production process. Now, this is the engine that we can develop, and the source to that is your production plan, your shift plan, which is the the manpower roster model mix, and then you have station data, how each station performs, what are the parts planned on it, how is the material supply, time per unit that it takes depending on the model, the manpower assigned to it, how long it has been running, its energy consumption and quality. These are all the inputs that you will get largely from the enterprise functions, MES, CAD, CAM, CAE, PLM, and ERP. And then you have historical data of plant events or safety events, and these are all stored in the data mart. Once this data is there, you can generate your trend analytics and reports and analysis. And the data patterns can be established, and the predictive modeling of how the system is behaving can be generated. And the extraneous data like geopolitical, tariff wars, or even minor issues or political upheavals can be put as input to this for this AI/ML model to get as close to the reality as possible, and then predict how we should plan our production given all the sources of data that we get. Now, why are we doing all this? If you look back, we have got the data, we have got enterprise applications, we have connected plant, we have connected machines. The end goal of all this is to ensure our production is smooth, it is efficient, and it is profitable. Now, these things mean different things to different people. If you take at the executive level, they will look at our cost of operations, compliance, safety, flexibility of capacity for opportunistic surge in demand or drop in demand. And then these tools would drive improvement in turnaround time and improve the product mixes that can be taken to market. For tactical leadership, like the plant managers and others, they would want to know when their machines are going down, what is the sustainability report on this, and what are the safety of the plant, so that they can run the shop efficiently at optimum cost, ensure quality is ingrained into the product. At the same time, the equipment that is used to manufacture is at a optimum health. At a plant level leadership, they would want different kind of parameters to be constantly reported, and they would want what is the production value, what is the volume I'm going to manufacture, what variants and what quality effectively, and what is the sustainability. And the outcome is improved efficiency and leads to managed uncertainty and reduced wastage. So if you take plant operational view, once the input comes in, as the data passes through as a part passes through the various stations, we would like to ensure that the output part is what meets the production quality, design, and performance, which again takes us back to the same thing can be visualized in the digital twins we talked about a little while back. Now, what should be the recommended focus for all discrete manufacturing segment, small and medium business or even larger, is to focus on the outcomes to business. Line level outcome reporting will give the line managers tools to address challenges. Plant level performance metrics for the plant managers and ensure that the plant is performing to the levels that is desired. And the executive leadership would look at all the data and then take strategic decisions to whether to introduce new product. If the product is not performing, should we stop the product and move on to the next product from that the market needs, and things like that. So these tools can help focus on the outcome. They can also predict some of the behaviors of the product as it gets into the market, and we constantly get feedback from the system and make sure that the outcome impact to analysis is to support decision support systems and suggest corrections. Then the algorithms, AI/ML algorithms, can identify the data patterns and correlate for the leadership to make sure there is data-driven decision. And then, of course, last but not the least, is to fine-tune the process as we go along to ensure that the process is efficient and is meeting the business need that the plant has set out to meet. That brings me to the end of my session. Any questions?
Thank you, Satya, s- for that wonderful session. Um, so we are also monitoring the Q&A part of our webinar to post questions, and I will also request the organizer, Karthik, to enable the mic so that people can ask questions. But in the meantime, there have been a few questions which were submitted when the webinar was set out and people were registering for it. So one of the questions asked was, how can older production production plans generate data?
Yeah, so there are multiple ways in doing that. Let's say these are not connected machines. So there are one option is to retrofit it with PLCs and other devices to generate data as the machine operates and share that with the MES system. That's one option. The other option is let the operator or the user who is using that machine or that not non-connected machine input that data into a system which can be consumed by the MES or the ERP systems.
Okay, thanks, Satya. Another question asked was, I know you touched upon AI, but people are asking, how can AI play a role in improving production efficiency?
How can AI play a role in improving production efficiency?
That's correct.
Okay. Okay. Let's again, AI is largely driven by the data that is being provided to it, right? So, if production efficiency is to be improved, we have to ensure that in the given slot and the given time, the plan is such that the throughput is maximized. If that is the goal, that would improve efficiency. Now, to throughput to be maximized, you will have to look at your entire production process. Once the data is captured, you will know how much machine is time each machine is taking, how much setup time is there. So when you do the planning, the AI can sequence the plan to either to maximize throughput. That means that it will reduce number of setup changes at different stations to improve your throughput. So that is one way of improving efficiency. So as we can analyze the data from all sources, AI can throw up various options. In fact, there are tools in the market today which can take a production plan, you can add constraints to it, and then it can generate a best sequence for a desired outcome. It could be for maximum production of a specific part, or it can a combination of specific parts in a day. For example, if you take Alto as a Maruti 800 as a car, it is a platform where there are n different models. Now, if you have to ensure that the efficiency of the 800 assembly line is maximum, the AI tools can basically tell you at what model mix you should go through this assembly line, or you can plan your production in such a way that you adopt a model mix recommended by AI to ensure you get the outcome that you want. That is the meet the production plan. So that's how you can improve your efficiency, and that's how AI can help in optimizing your production.
Thank you for that, Satya. One of the people who have joined the webinar has asked, can SAP B1 HANA integrate with MES? And also there's a question, is MES SAP software or a different software? I think if you can just explain the MES concept a little bit, I think that will give clarity to this question.
Can you repeat the question, please? SAP
So the question,
and MES. So, is
yeah,
the
the question
question?
is, is can SAP HANA integrate with MES? And
Yes.
I think there is a clarity question more, that is SAP MES or are MES considered other softwares? I think if we throw names like
Okay.
uh, Ops Center and
Okay, got it. So SAP is a enterprise resource planner, which means that it takes care of all the enterprise functions. Now, what are these enterprise functions? You have HR, you have finance, you have material procurement, and you have MRP, you have inventory modeling. These are all enterprise functions that are critical for the enterprise to function. MES is more focused on executing a production plan. Once a production plan is given to the shop floor, MES picks it up and then schedules all the jobs on the shop floor to ensure that the production plan goal is met. Let's say if your production plan says you should this assembly line for Maruti 800 should produce 10 Maruti 800s, 20 Alto K10s, and 30 Alto VXI. They would have come up with that based on the market demand. To do that, the MES will take up the resource planning at various stations to ensure that the production is met. For example, a VXI would require a different set of parts compared to a Maruti plain Maruti 800 or a Alto K10. These are all the same platform. The same assembly line will manufacture all these plants, all these cars. So at different stations, as a 800 progresses through the assembly, the parts have to be made available at that time. So the MES will do this planning. All this data can be integrated with ERP. What data goes back to ERP is, you have given a production plan of n number of cars of different models. At the end of the day, has it been produced? Next, what parts are to be made available at what time, at what stations? That inputs obviously ERP can provide, because it knows the entire production cycle for a 800 or a K10 or a VXI. Now, the actual production can go back, so that the ERP can know how many cars are there in stock that are produced today, and then it will go through the yard where they will get ready for shipping. So MES takes care of largely manufacturing processes and plants, and it can integrate with SAP S4 HANA. And there is that the end goal is that to make sure that the blood flows through the vein to all parts of the body smoothly. And in this case, the data that is generated at various sources is the blood for the organization.
Thank you, Satya. I also wanted to let all the participants know that the microphones are on, so please feel free to step in, ask any questions as you may. Thank you.
Mr. Satya,
Yeah.
Zia here. The same question which I asked actually. So my question was that the SAP B1 HANA can be integrated with the MES.
Yes.
Okay, and MES is a software of the SAP company also, or some different companies are offering MES software?
MES stands for Manufacturing Execution System, and there different companies are offering these softwares.
Okay, okay, got it. Thank you.
Just to add to that, sir, as an organization, Kripya also has its own platform called Central Stage. That is our platform for connecting with IoT devices.
Okay.
Again, as I said, we still have about 3 minutes. Please feel free to ask questions. There were other questions also posted, like how can IoT, how can IoT help in processing supply chain data for production planning? What data is needed?
So, okay, IoT can help in your production planning once your production plan is laid out. Like I said, for the Maruti 800, three different models, K10, 800, and VXI, your different parts are required at different places. Now, your stores are equipped with IoT devices which knows how many parts of a particular VXI, K10, or 800 are there, and how many are in store, how many are there in your shop floor. So, so as you plan your production, you know what is your inline inventory. So that means that yesterday you produced X number of part, you possibly did not complete your production plan. You were produced less, so there is some lying in your inventory. So when you actually reorder those parts from your store to your workstation, you can take into account of those items that are there. So how would they know? Because these parts are all placed on various sensors and there are barcode readers, so you would know exactly what part is where. And once you know that, you can correspondingly adjust your material requisition to your stores. So because I already have these parts at this station, I need less of let us say my dashboard dashboard of the car, or at another station, if there are tires that are extra, then I can need less of those tires, or I've run out of tires there, I can order more tires at that station. So that's how IoT is. What is IoT at the end of the day? It is sensor that is telling you what is where and where at what level it is. So if you have that data from the store or from the shop floor, your entire production plan can be plan includes ordering material, so that can be fine tuned. And in addition to that, of course, AI can help you optimize your plan.
Thank you, Satya. One last question which was placed earlier was, how is data security handled and what is the risk of data breach in this whole ecosystem?
See, data security is inherently is taken care in the enterprise applications. Now, data in transit is all encrypted from the device to the gateway to the various sources. So, data breach is protected. Data is protected at various layers. From, let's take the journey of a data element from the sensor to the gateway. So once the sensor to the gateway, at the gateway, it can be encrypted and transmitted to the cloud, and all the way it is protected through two-factor authentication in that particular organization. So, and then as it goes back from the controls, where they find that there is a particular temperature that's going back up, the data again is sent encrypted to the gateway, decrypted there, and then the actuators are activated to ensure that the temperature doesn't go above particular limit. So inherently, lot of these enterprise applications, MES applications, and the devices are secure. The only point where there can be a possible security is where if there is a Bluetooth based data transmission happening from a, let's say, a temperature sensor. That is where possibly there is a risk, but even that today can be encrypted and ensure that they are not breached, because access to those Bluetooth devices can be protected.
So one of the questions posted was that can we track manufacturing cost of products and how will information flow? Again, if I've asked the question incorrectly, whoever asked the urgent question, please step in and you can raise the question.
So the question is, can we track production cost?
Yes, manufacturing cost, and then how the
Yes.
information flow for that information is flows.
Yeah, let's say, for example, in a again, manufacturing costs can be tracked all the way across. The cost of quality, cost of production, cost of manpower, cost of power, everything can be tracked, because once the devices are all connected and the data is coming in, cost at every level. If, let us say, for example, again, I'll go to the Maruti 800 example. If you are manufacturing a Maruti 800 at a particular assembly line, at the end of the assembly line, the value added, because all the parts that are getting assembled. So once the parts are all there, the cost of all those parts to reach to your station where it gets assembled, including your labor cost and the transport cost. So those costs are known. As the parts get assembled, the power each of these machines are consuming, the amount of labor you have involved. So when you collect all, the ERP gives you the labor cost, the time that it spends in assembling it is coming from your MES. And when you put all this together, at the end of the day, the cost of manufacture can clearly be established.
Okay, thank you, Satya.
Thank you.
Thank you again, all the participants, for your thoughtful questions and active participation. The recording of this webinar will be made available to all registered participants. If you have additional questions or feedback, please don't hesitate to reach out. You can reach out either at sales@kripya.com or innovate@kripya.com. As we come to the close of today's session, I would like to extend our sincere thanks to each and every one of you for joining us. We trust that the insights shared have been valuable and thought provoking. On behalf of Kripya Solutions, we wish you continued success on all your initiatives and look forward to welcoming you to future events. Thank you, everyone, and have a wonderful day.
Thank you.